I'm Andrew Chu, and I'm here to present the radiation and propagation of waves. So, to start off, what are radio waves? So, radio waves, these are a type of electromagnetic radiation best known for their use in communication technologies such as television, mobile phones, and radios. So, radio propagation is the way radio signals are transmitted from one point to another inside the Earth's atmosphere or free space. So, Heinrich Hertz was the first to identify and study radio waves in 1886, and Hertz became the first person to transmit and receive controlled radio waves in the 1880s. So, for a few definition of terms, free space usually refers to a perfect vacuum, and all radio waves traveling at free space travels at the speed of light. The troposphere is the lowest layer of the Earth's atmosphere, and the ionosphere is defined as the layer of the Earth's atmosphere that is ionized by solar and cosmic radiation. It is the boundary between Earth's lower atmosphere, where we breathe, and the vacuum of space. So, for the optical properties of radio waves, since light waves are high-frequency electromagnetic waves, the optical properties are similar to radio wave propagation. So, here are the four optical properties which are mainly affects the radio wave. So which are refraction, reflection, diffraction, and interference. So for refraction, or which is in simple terms called bending, it is the change in direction of the electromagnetic ray upon passing through one medium or another to another. So when a ray passes from a less dense medium to a denser medium, it is effectively bent towards the normal. So here is the normal. So when it is assuming this blue side is the denser medium, it will it will bend towards the normal. So having a smaller angle of refraction. So when from a higher medium to a lesser medium, it will bend away from the normal, which will have a higher angle of refraction. So for the second, which is the reflection, or in simple terms, bouncing, in electromagnetic reflection, this occurs when the ray hits the boundary of the two media, but not all of the incident power enters the second medium. Only a few enters. So the waves that do not enter, for example, this one, are reflected. So if not all of the waves enter this medium here, so it is reflected in respect to the normal. So the second here, if it is a rough surface, so the angle might vary. The third is diffraction. So for diffraction, it is the phenomenon that allows the radio waves to propagate around corners. It can be defined as the redistribution of energy or modulation within a wave front as it passes near the edge of an opaque object. So we can see here that this the receiver and this the transmitter. So this direct line of sight. A signal might still be received by the receiver because it is diffracted here at the point where at the tip of this shade. So it has a weaker signal, but at least the receiver might still be able to receive the message from the transmitter. So it is the same concept with when you're in a dark room. So when you're in a dark room and the door opens with the light outside, here you can see the direct line of sight of the light, and here it is diffracted, so illuminating the room. So the fourth one is interference, or simple words, colliding. So this happens when two or more waves simultaneously occupy the same point in space. So it adopts the principle of linear superposition, in which when two or more waves come together, the result is the sum of the individual waves. So the interference degrades sorry. The interference degrades the system performance of the waves. So here we have the radio wave propagation modes, which are the sky wave propagation, surface wave propagation, and the space wave. So for the first one is the space wave propagation. So for the space wave propagation, it includes both direct and reflected waves, occurs within 20 kilometers from the Earth's surface, which is the troposphere. So for space waves, um, the direct waves are line of sight of propagation. So it includes three components, which are the direct waves, or the line of sight of propagation as the signals are sent in a straight line from the transmitter, which is this one, and it travels only a minimum distance of sight and hence affected by the curvature of the Earth. The second component is the ground reflected waves, which is this one. The waves are reflected from the ground and into the antenna. So the third one is the tropospheric waves, which are the reflection uh, from the troposphere, as you can see here. So next we have the surface wave propagation. It is also called ground waves. These are electromagnetic waves emitted from the transmitting antenna, propagating along the surface of the Earth. So ground waves are restricted to small distances because as they travel over the Earth's surface, they bend along the curvature of the Earth. The results in energy losses. So attenuation of the waves also occur because of the eddy currents induced at the surface of the Earth, as well as different conductivity on different terrains. So this one is commonly used for ship-to-ship and ship-to-shore communications, for radio navigation, and for maritime mobile communication. So it has a frequency of below 2 megahertz. So the last type of propagation, which is the sky wave propagation, uh, it is preferred when the wave has to travel a long distance. This because the wave is projected onto the sky and is again reflected back to the Earth. So here the waves are shown to be transmitted from one place and where it is received by many receivers. So this one can be a receiver, also this one, and this the main receiver. So it is an example of broadcasting. So the waves which are transmitted from the transmitter antenna are reflected from the ionosphere. This is the ionosphere. Such travel of the wave from the transmitter to the ionosphere and from there to the receiver on Earth is known as sky wave propagation. As discussed earlier, an ionosphere is the ionized layer around the Earth's atmosphere which is suitable for sky wave propagation. So that's it for the radio wave propagation, and here are my reference, and thank you for listening.
The moments